All right. Good morning, everyone. We're happy to have you today, Friday, July 16th for 2021 SciPy. And the schedule for the day, we're going to start with a keynote. By the way, my name's Eric Jones, CEO at InThought. And we're going to start the day with a keynote for Fernando Perez. And then we have 4 different tracks today: data visualization, image processing, machine learning and data science, earth, ocean, and geo and atmospheric science, and then a maintainers track. And then the ever popular lightning talks are at 3 to 4. And then we move to GatherTown, which is another platform, as you're aware. Make sure to make that transition, and we'll have the BOFs and the poster sessions in that. And there is a bit of a surprise there. John Geyer has made a virtual version of part of Caltech, where SciPy started many years back and was for 10 plus years. And so that'll be part of the GatherTown experience. So thank you, John, for doing that. Our sponsors for the day are the silver sponsors are MakePath, which is a geospatial analytics company out of Austin, Texas. It's nice to have a local doing that. Thank you very much. And then USGS is a little bit involved in geospatial data as well. So it's nice that those two are paired together here. Thank you so much to USGS, who has been a longtime sponsor and important to the SciPy community. We really appreciate that. Sprints, which are coming up this weekend, are always so much fun. Very much hope you go to those. Are sponsored by ARM. We're appreciative of them for doing that. And then hidden, because they are so bashful, is Nist here. Nist is also a sponsor of the sprints, but they are bashful about their logo, and so it can't be on there. But that doesn't change the level of support. In fact, it makes it somewhat more charming that they do it. So thank you very much, Nist, for also being a Sprint sponsor. Announcements: signing up for lightning talks. We have you need to do that on the Slack announcements, hashtag SciPy 2021 announcements. So that's where you can go for that. Stay connected. We need, if you're Twittering and Instagram, then make sure you tag those so that people can find them. And of course, it's a great community. Make sure that you abide by the code of conduct so that everybody feels welcome. There's also SciPy merch available on our website, or on the SciPy website. And so be sure to pick up your shirt or sticker there. They're quite cool this year, so grab them while they're hot. And it's really important that we thank the folks that have made this all possible for us. There's so many that we're going to talk about here. But the organizing committee chairs have put in a huge amount of work to make these virtual days that we've had together work out so well. And so thank you very much to them. I want to say a particular thank you to Jonathan Geyer and to Corin Webster for all their help and the effort they did in co-chairing this year's SciPy. And then there's a key shout out here to Kristen Leiser too for the logistics. It's a lot to put on one of these conferences, and so thank you to them for doing that. Hands all around, right? All right. So also we have the chairs for the tracks and the mini symposia listed here. Thank you to those who have set those up. And then the Proceedings Committee. Many of you are able to come to the conference because we now produce a Proceedings, which went through a huge amount of effort to get that started, probably 5 to 10 years ago, and it's been being produced ever since. And it's a lot of work. So thank you to the team that does that. And then a whole host of other people working on the programs and the tutorial committees. So we really are appreciative of all of these folks for doing this. And that's a good lead in to next year. We'll do it all over again, hopefully in person. But it's going to take an equal amount of effort and organization. And so your opportunity to really join in and pitch in the community is available. And so sign up to be a volunteer if you'd like in any of these areas. There are a lot of different places to get involved. And so please become an active part of the SciPy conference. We'd love to have you. Also, unbelievably, SciPy is 20 years old. We were just talking in the backstage room, Fernando and I, about the very first SciPy, and we remember it being in kind of this long shotgun hall sort of room at Caltech, perhaps in the mechanical engineering department. I can't remember. And then by the time John had started with us, we had moved to the Beckman Hall, and that much nicer venue. But it's been many great years building a community and building tools that have been really world changing. So thank you to the community for all of that. All right, and it's very appropriate that our keynote today is from Fernando Perez, a person that many of you already know very, very well. It's very nice to have him, and he's really been here from the very beginning. He started life in Columbia, so he's a Colombian, and I think you went to undergrad in Columbia. Is that right, Fernando? Yeah. And then you moved to grad school at the University of Colorado studying physics. And my memory of my discussions at the time, I was in grad school or finishing up grad school, and I didn't understand at all what Fernando was doing. It was this higher order math stuff for differential equations. Very cool, but also very geeky. So that's where he got his PhD. And you know, my first recollection of getting to know Fernando was through late night Yahoo chat sessions together. And we would spend the time talking and debugging code. And a memory that I came up earlier this month, actually, in some discussions that I really remember well was that Fernando used a flavor of Linux called Mandrake. And he was getting crashes that no one else was on a tool that allowed us to inline C++ with Python. And, you know, the easiest solution to this would have been to convince Fernando not to use Mandrake. But that really wasn't an option at the time. And so we spent, I don't know, probably 2 or 3 nights going through, sharing snippets of code, going back and forth. And what we learned was that Mandrake had linked their GCC, set it up when they compiled it so that there was a bug. And any code generated by GCC on Mandrake, if you called had a C++ function that called a C function that called a C++ function, so your call stack went from C++ to C to C++, and then you had an exception in C++ as it unwound through the C stack. When it went from C back to C++, it seg faulted. And so that absorbed way too much of our time. But it was also a huge bonding experience and an opportunity to get to know each other very well, all the cussing included, I guess. but it's also a nice window into what we spent most of our time on. And that was these esoteric, crazy issues with threading and with crazy different platforms and the errors that would come up on them. And all the work that we did early on, which many people did, that allow us to now say pip install SciPy, and it just works. And so that's what the trenches were, I guess, at that time. The other thing that I remember about Fernando is having dinner on my back porch one evening, and at the end of the meal, Fernando plucking a raspberry out of the fruit bowl and proceeding to explain the operation or the idea of an atom to my 4- and 6-year-old children, with them in rapt attention, as many people are. Fernando has quite a big personality, and they just loved listening to them. And now that 4- and 6-year-old, one is studying physics in college, and the other one may be as well. So, you know, it goes far beyond just the science that we do together, and the times that we get to share together in a community like this. And of course, that personality that Fernando has played a large part in the success of IPython and the Jupyter Notebook world, because nobody does these things alone. And it's also it's often a good measure of someone to see the team that coalesces around them. And by this measure, Fernando has set a high bar. Folks like Brian Granger and Benjamin Reagan Kelly, to name just a couple, have been partners in crime for years with him, and really instrumental in the success of the project. And so, you know, hats off to Fernando in building that team, and also to the team in general for having such a huge impact on our working lives and to millions of other people working lives. There's also, beyond this kind of impact that Fernando has had with Jupyter, the Jupyter project, he's also had an impact perhaps that some of you aren't as aware of, that maybe are going to either are in scientific academic positions or hope to be in the future, but find yourself in this world where you have one foot in research and one foot in really a passion about building tools and software. Fernando has really lived this along with a number of other folks in the community. But to my knowledge, Fernando and Brian are the only two folks, or at least certainly early folks, to have built a tenure argument around open source software, and have been successful at it at Cal Poly and at Berkeley. And so that's a huge transition that now, instead of just being valued for the papers and teaching that someone does, you can also look at the community contributions that arguably are much wider in the impact that they can have. And that's now being recognized as critical. So as you move forward in your careers, hopefully there is more space for folks like that really want to make their contributions in the open source world. You know, Fernando is now a professor of statistics, which points out that we're not all the way there yet, I guess. That the place where he found a home is certainly sort of on the outskirts of what his career has been. But the place is there. And so thank you, Fernando, for all of that. And, you know, it's having a big impact as well if we look at Berkeley and the growth of data science and the things that have happened there. Fernando's been a major mover in those, now there's a movement even to form the first college in 50 years around this concept of data science and computing and society and how those fit together. And so a lot of that is based on really Fernando's path through a career and the impact that he's had and others have had in the data science and Python world. So with that, I'd like to turn the stage over to my very dear friend, Fernando Perez, and to present at the 20th year of SciPy.
Eric, thank you so much. I'm blushing. It means a lot, I'm really humbled by this introduction, and it's extremely meaningful to have a chance to be here today with all of you. Thank you. Thanks, John, for the invitation, and Eric, really, for that absolutely incredible and moving intro. The themes that Eric touched upon are going to be some of the themes. Let me see if I find again my share here. Let me share screen. And let me go to the right Chrome tab. Okay, here we go. And so the themes that Eric alluded to are actually some of the themes that I would like to kind of discuss with you all today. It's both a bit of a retrospective and of thinking and looking forward. But as Eric said, this story for us started back in 2001, and the theme of this part of my presentation will be one of gratitude. As I said, first to be invited and to have the opportunity to be here. But as Eric mentioned, I did my PhD at CU Boulder, and my PhD was in physics in QCD. This was the Raspberry. I think the Raspberry discussion was kind of inspired in some sense by the work that I did in QCD, and I did a postdoc in applied math that I remember actually talking at one of these early SciPys about that research, which was conducted in Python. But I also spent a lot of time procrastinating in the mountains, as one does when one goes to live in Boulder as a grad student, on rocks and ice in the neighborhoods. And importantly, I had a really difficult crisis in my PhD. I managed to, against the advice of my better informed and wiser student colleagues, I managed to pick as my first PhD advisor probably the most toxic personality in the whole physics department. And I was actually fired on my 5th year as a PhD student, which is not a great career move to be a foreign student in the US and get fired at the end of your PhD. That put me in a difficult position, and a wonderful theoretical physicist named Anna Hasenfratz sort of rescued me and offered me to finish the PhD. She was a co-PI in the QCD group. She was a co-PI in the group, and she offered to sort of rescue me by finishing a project I had started with her. But it was during that crisis that I basically learned about Python. I was using Perl at the time to kind of babysit my simulations and data analysis workflows. And I fell in love with Python. IPython was kind of an afternoon hack, is what I told Anna that I would do. I would kind of go away and play with this language, write a little bit of code and go back to work. Well, it's 20 years later and I'm still here. So take that as the quality of my time estimates. But importantly, IPython from the very beginning was a collaborative effort. I actually wrote some code, which is available up on GitHub, a few hundred lines of code, and very quickly I found online 2 pieces of interactive Python shell-like tools, and I contacted the authors, and they both, one of them, Nathan, was actually a grad student at Caltech, and I ended up meeting him at one of these early SciPys, and Janko is an oceanographer in Germany. And they both said, look, take our code, do whatever you want with it. I'm too busy right now to work on this project. But they kindly offered their support. And I announced IPython in 2001, the very first version. That's the first email from the main Python mailing list. It's kind of interesting to go back over that email today and see how actually many of the features that we still see in IPython and the kind of Jupyter workflow were already there back in 2001 in this little bundle of code that I made from merging Janko's, Nathan's, and my code and dumping it out into the community. So first of all, that marks those 20 years. And I also want to convey congratulations to Nthought, because Nthought was also started in 2001, and Eric has done a terrific job leading a company that has been incredibly critical for the success of this community. And so this year is kind of a multi-celebration for related projects in our community. But something happened early on in 2002, while remember I was in the middle of this kind of deep personal crisis of how do I finish this PhD, which was that folks in the mailing lists began to say, oh, this IPython thing is actually cool. Actually, Yanko was still around and commenting, and Travis Oliphant said, why don't we include IPython with SciPy? And to me, that was huge because it meant that what I did, even if I wasn't going to be successful as a physicist, somebody cared about what I was doing. And that was extremely meaningful. And finding that support actually gave me kind of the energy to continue. And I can really say that I wouldn't be here if it weren't for this community. Those little screenshots that I had earlier in the previous slide are actually screenshots taken from my thesis, from my PhD thesis made with Mayavi. And these are screenshots of the actual LaTeX of the printout of the PDF of my thesis. This is the cover page. And in the acknowledgement section, I actually did thank Prabhu Ramachandran from the Mayavi project, and who's worked at Nthought and is kind of part of our community, and Eric. And I obviously couldn't find a screenshot of the Yahoo Messenger sessions that Eric was referring to today, of our sessions. I don't even have a Yahoo account anymore, but I did found a screenshot of Yahoo Messenger because I distinctly remember those late night kind of chatting sessions on Yahoo Messenger, debugging those bizarre GCC bugs on Mandrake. And to me, it was inconceivable that this guy who was the founder of this company and who was, to me, this incredibly important figure in this space that I was getting into would spend time just chatting with me over this to try to help me fix a problem. And I did graduate. I probably wouldn't be faculty today if I hadn't actually graduated. But the year after I graduated, Eric Jones actually said, why don't you come to SciPy and give a talk? I was starting a postdoc. I was pretty bruised from that really painful PhD process. And Eric said, just come. I'll pay for your trip. Because I said, I can't really go there. I'm just starting a postdoc. I don't have funding for that. I'm not being paid to do this open source stuff. And he said, just come. We'll cover your expenses. What you're doing is cool. And that generosity put me on a path that changed my life. And I remember the reason that picture is there because the only way I could give thanks to Eric was I made a print of a photo that I'd taken of the Boulder Flatirons from the top of the physics tower at CU, and I printed it and brought it to him as a little token of gratitude. But I hope the best way to pay that is not to give more pictures back to Eric, but actually try to pay it forward to the rest of this community that has made our lives kind of so meaningful in these spaces. At that first conference, I had the chance to meet in person John Hunter, who at the time was starting Matplotlib. John had actually contacted me with a patch to the plotting parts of IPython in 2002, and I told him, "Look, I'm sorry, but if I don't graduate, my world is really going to fall apart. Give me a few months, and we'll talk again later." And John was not someone to wait around, and so he said, "Well, I'll go and start my own thing then. If you can't accept patches to IPython right now." We met in person in 2003, and this was truly love at first sight. We became incredibly close personal friends. We built a decade of an amazing friendship, which sadly ended when John passed in 2012. Many of you remember him. We're still using Matplotlib and building on his legacy. He co-founded NumFocus with us that year, right before passing. But those are the qualities of relationships that we've built in this community and that we hope to build with others now. SciPy truly made my career possible. I can't possibly thank everyone who has been a part of this process, but at least I want to touch on a few figures who were important early on and who are still leaving an impact. So Jared Millman and Stephan who continue to be very active in our community, were folks that I met in that period. And we had a chance to connect precisely with Prabhu. His wife, who actually KD defended her PhD this week in ecology, in Michigan, and we traveled to India in 2010 to see the amazing work that the Indian community has done with the FOSSI program to build open tools for research and education across the whole country in a systemic way. And connecting with Jared and Matthew Brett at Berkeley led me kind of to the rest of my career that has given me kind of a path for today. But in the IPython space, as Eric mentioned, back in 2004, I didn't meet Brian. Brian and I were actually friends from grad school. We both did our PhDs together in the same program at CU Boulder, but we reconnected on the way back from a SciPy conference where I was headed to climb in Yosemite. I stopped in the Bay Area. He was faculty at Santa Clara, and we started talking about Python and IPython, and he was doing stuff on parallel computing. And out of that late night conversation over ice cream at Brian's house started a collaboration that is probably the most meaningful of my career. And Brian quickly introduced his brilliant 18-year-old student, Min Reagan Kelly, to the idea of working together on this Python stuff. And Min actually a couple of days ago posted this on Twitter, where he actually found his very first commit to IPython, which was a space, and the message said test. So testing basically that he could commit to Subversion, or CVS probably at the time. This is probably from the Subversion port. And obviously, Brian and Min were just the seed of a huge community, that is really who we need to thank, and not just individuals. I can't possibly go over everyone, but it is in this incredible community that the credit rests, that the energy, where the energy really lives, and those are the people who make all of this possible. I see Carol Willing is here, and she has been an amazing leader in the project that I've had the privilege of knowing for a number of years and learning from her on so many fronts. And I unfortunately missed the session that she led yesterday, but because I was trying to finish these slides. But Carol and others in this community are the ones who deserve all the credit. I can't go over everyone in person, but the point is, this quote from Brett Cannon probably resonates with many of you. It certainly was true for me. I really started doing what I thought was geeky, techie stuff, but it was this sense of belonging to a group of like-minded people who wanted to collaborate and wanted to work together that changed my entire personal and professional trajectory. Something is missing, though. I'm sure some of you have noticed that I was mostly thanking a bunch of white guys. And that is true. Those were the people who were there in 2002, 2003, 2004. They were amazing human beings. They're some of my closest friends, but we still have a ways to go. And some of what we need to think about is, how do we build the future of these communities in a much more inclusive and broad way, where other voices are welcome. M. Pacer tweeted this yesterday. I saw it yesterday afternoon on Twitter about Carol's session, which, as I said, I sadly miss. M is part of the Jupyter team. And she works now at Netflix. And I don't know if that session was recorded, but I would love to see it. We are seeing change, right? There are initiatives now, very active on multiple fronts. This is just a thin slice of the work that is being done to make this better. The Scientific Python steering committee for the whole ecosystem does look very different, and that is a very concretely positive step. Leah Vassar, who I saw is also here, recently announced that her amazing PyOpenSci project that she leads from CU Boulder had been awarded a grant specifically around building human capacity and diversity in our community. NumFocus has been doing a ton of work on this front, and so have many of you. So we do have change in the right direction, but I want to acknowledge that we still have a ways to go. Now, with this community and these tools, we've built a lot of impact, and I think it's worth at least recognizing how far we've come for a second. So these are a couple of snapshots of the kinds of talks that I was giving in 2004 at conferences, where basically it was like, why Python? Python is cool. You can do actually real work in it. And here's a list of a few people who are doing, and this was probably a quasi-comprehensive list of the Python projects, kind of the high-profile Python science projects of the time. Yes, and Beamer for the person asking on the chat. But today, it takes a village to get the kind of impact that we're having. This is just a bunch of screenshots from the sponsored projects and the affiliated projects at NumFocus, and it's big, right? There's a lot here, and we are having impact in important areas. Some of you may recall that a little over 100 years ago, Einstein predicted that gravitational waves would exist, and we would be detectable with sensitive enough equipment. They would propagate as ripples in space and time when masses accelerated. And in 2015, 2 black holes went boom in the night, 1.3 billion light years away. And this is a screenshot of the first figure of the first LIGO paper that led to the 2017 Nobel Prize in Physics. And it's all NumPy, it's all SciPy, it's all Matplotlib. It's available if you want to hear the sound of 2 black holes slamming into one another. That little whoop is available to you as, if you go to that URL, as a binder that you can run without installing anything. All of this is now powered by our community. John Hunter would have gotten a kick out of that, because I remember he used to scan the literature and the archive looking for telltale signs of Matplotlib figures in archive preprints. And this is probably going to be one of the most cited papers in the history of physics, that figure, and it's all made by the tools that this community has created. And more black holes. In 2019, you may recall the first direct image of a black hole was made. I happened to be at Berkeley in the physics department the day after the press release went out, when Shep Doleman gave the first public seminar about it. I took that picture in LeConte Hall on campus. The very first public talk about it was given on campus at Berkeley the day after. He's from Harvard, but he was in the West Coast. And Katie Bauman the day after gave a talk about the imaging, her work on the imaging side of things. I couldn't even take a picture of her giving that talk, because even though I went half an hour early into the conference auditorium, it was already overbooked, and I had to listen to it from outside on the overflow speakers. But all of that work was done with Matplotlib and the SciPy stack. And I had a chance a few months later to give a talk at EPFL next to Katie, where she presented not only her work, and by the way, that if you haven't seen that, it's an incredible data science talk and kind of beautiful science talk that I encourage you to watch. But she presented this analysis that GitHub did of the kind of stream flow of contributions that went into the EHT toolchain. And it's about 23,000 people who have put their code into the tools that made this kind of science possible. And if you watch the video, you'll see many names of projects and people and GitHub repos that you'll recognize popping up. And then a few months ago, actually, again, from Caltech. So there's a Caltech thread running through this. This is a screenshot that I took during the press release of JPL, during the kind of press conference of the JPL team controlling and receiving telemetry from the little helicopter that went up on Mars. In that window, those of you who do a lot of Matplotlib plots that pop up windows, not in the notebook, will recognize that's a Matplotlib window. So the very first time that we got an aircraft on a foreign planet, we got the telemetry from that milestone for humanity down into a Matplotlib window. It really is a remarkable achievement from this community, and it's reaching the general public. So The Economist a couple of years ago started publishing some of their analyses with their code, all of it pandas, etc., as Jupyter notebooks to basically connect with the public in a more reproducible way. Oh yes, for the question, it's not sound; it's sonification of data. I should have clarified that. The data from the black hole is basically stress measurements from an interferometer, which is what LIGO is. But you sonify that data in order to be able to listen to it. But it's basically transferring to the acoustic domain data, which is really stresses in motion from the mirrors on the interferometer. And we've been recognized in places that I never thought this would happen, but Nature a few months ago published kind of a review of the 10 most significant pieces of code that have transformed science, and our tools were there. And even though they listed IPython Jupyter, I think of it strictly as the work from this community, because obviously Jupyter would be useless, IPython would be useless if the rest of the tools didn't exist. It's but a gateway into our ecosystem. And so this is, in a sense, a recognition that all of this combined work from this community has really made an impact. And not just in research, but in education. At Berkeley, we teach very large courses in data science. And the textbooks are available live to the students for them to just click on a button and be logged into Jupyter Hub hosted in the cloud, where they can run without barriers and without having to install or purchase anything, all of the classwork. And that makes this kind of scene possible. Obviously not right now. This was back when we taught in person. But at the top is Zellerbach Hall, the theater on our campus, hosting Data 8, our introduction to data science. And at the bottom, I'm teaching in Wheeler Hall, which is the largest classroom on campus, not the theater. I can't even teach that class. I'm going to be teaching it this fall, but it has to be online because that auditorium only fits about 800 people, and we've gone over that capacity. These are the fastest courses in the history of Berkeley, the fastest growing courses in the history of Berkeley. And it's really changing the nature of the campus, basically to the point where for our students, doing email in a browser or analyzing data with pandas and matplotlib and the SciPy stack are completely natural activities. That's kind of how they think about their world. And this is now has been turned by campus into an annual workshop on, or the teams who build this have developed a national data science education workshop that I encourage you, if you're interested, to participate next year. And I think the recordings are made available because it's not just about the tech, it's also about the pedagogy and the many other aspects of teaching data science at scale. And as Eric mentioned, what used to be called, or what is currently called, the Division of Data Science on campus is actually in the process of becoming a college. We haven't had a new college at Berkeley since the 60s, and in a meaningful way, the work of this community has contributed to making all of this possible. So it's all good, right? We won. Mission accomplished. Let's call it a day. Well, not so fast. William Stein was a mathematics professor at the University of Washington, fully tenured. He actually gave a keynote about SAGE at SciPy 2006, if I recall correctly. And despite having had successfully funded parts of SAGE with grants and whatnot, he wrote this blog post a couple of years ago about basically, if I want to continue building some way of sustaining SAGE, I'm going to have to quit my research and education work and devote myself to building a company for that. Nothing wrong with having a company, but William wanted to do mathematics research and couldn't sustain that. We have a model which is unsustainable in a variety of ways. We have too much ad hoc volunteer work. It's wonderful to be open to volunteers, and many of us have come to this community that way, but relying strictly on that is dangerous because only those who can afford to volunteer can participate. And if you are the breadwinner in your family, if you have children, if you're a minority with economic pressures or family pressures of other kinds, it's going to be much harder for you to enter this community if it's predicated on having spare nights and weekends to build your GitHub portfolio. Tasks that are what I would call structural are not well funded. Academic careers, as we've mentioned, are extremely tricky to sustain. And our relationship with industry is complicated. Nthought, Anaconda, QuantSight, QuantStack are companies, and new ones like Coiled are companies with which we have a deep relationship of partnership because they believe sincerely in open source. The relationship with the bigger companies is not always an easy one. There's complicated tensions there, even though they also contribute a lot. I don't want to deny that. And we have directly benefited from the generosity of Google and Amazon and Microsoft and others. But it's a complex relationship that we have, and I don't think we have fully figured out. And so I want to, for a few minutes, frame the idea of how we've been thinking in Jupyter about software in the context of trying to examine how to get things funded and supported and developed in a more sustainable way. And the first point is that the software is only a piece of the story. This is obviously a little bit of a cartoon abuse of Maslow's hierarchy of needs, but I think it's useful to realize that there's layers above and beneath the software that are critically important in the long run beyond just the code of that one repo on GitHub, where it is fun to play and where we develop the technologies. But many people come to our tools because they have a story to tell. They have data to analyze, they have a paper to write, they have a class to teach, they have a problem to solve for their clients. And that layer of contents and services is actually kind of the tip of the spear where we have impact in communities but it requires a different kind of maintenance and processes and development than just putting code up on GitHub. And beneath the software, for example, in Jupyter, we've taken a lot of time to abstract and clarify and document the ideas that Jupyter implements. An example is our communications protocol, which started for IPython, but later supported other languages. And we worked actually in person with the Julia team and with folks from the R community to build Julia and R kernels. And then by documenting that, the community has built many, today over 100 different kernels support the Jupyter architecture. And that work is done by others without even necessarily using our own tools, right? The point of a standard is to allow a bigger ecosystem to thrive beyond your own implementations and beyond your own software. The community itself requires a lot of management, and I don't think I'm telling anyone in this audience anything new here, but I think it's important to remember that most of us were not trained in any of these aspects. And in Jupyter, we continue iterating. This is not a finished job. In fact, we're currently going through almost completed a deep refactor of our governance, but we have spent a lot of time establishing practices for governance, for industrial relationships, for fiscal management, et cetera, so that these projects can be managed and governed in a sustainable way. And that takes a lot of work, and it's not the kind of work that is normally funded or rewarded. But I think it's important to think kind of that beyond the tools, these stories drive impact. Our ideas, if we present them in the right way, can fuel a bigger ecosystem. And ultimately, it's the people who make it possible, who provide the innovation, the resiliency, the variety of use cases that comes from many different voices, needs, and actors to really make projects and communities like ours possible. But all of that needs to be supported. And how do we do this for 20 more years? Because I don't think the models we've been using are going to completely last. Scientific open source has thrived in some ways, as we saw in these kind of this quick slice of successes. Obviously biased. You could pick equally interesting different topics in other parts of science, but it has been with very limited direct federal support. For the most part, many of these projects have been built kind of on the backs of other funding or people's nights and weekends, or kind of with wink, wink, nod, nod, doing software on a grant that was supposed to be about papers, the kinds of things that traditional funding agencies support. And in the last decade or so, actually private philanthropy stepped into the gap. And I do want to recognize these 4 people. There's others, they have bigger teams, but these people were really visionaries in using the power. These are all program officers. Carly, first at Moore and now at CZI. She's been kind of a constant thread in our community. And Dario now at CZI. And early on, Josh Greenberg and Chris Menzel were really visionaries. They were arguing for these ideas in 2010, 2011, with the purse of some of the richest private philanthropy foundations in the country, and they had an enormous impact. Off of that, today we're seeing a really interesting model in the CZI EOSS program, which really kind of, I mean, they're funding, I grabbed just random screenshots from some of the things that they're funding right now, and it's basically a laundry list of many of our projects in this community. But it's important to see how they're framing it. They're precisely framing this program in a much bigger, much more inclusive, and much more holistic way that I think makes a lot of sense and can be a model for further funding. Because this success that we're having is a version of what I think Tracy Teal, if I remember correctly, I think is the person from whom I learned this phrase of catastrophic success. This is a quote from a paper that came out back in 2015, where they were trying to look at citations in astronomy, in the astronomy literature, and seeing how already Python had overtaken IDL, which was kind of the standard in the field, kind of a cousin to MATLAB. That's actually why I replaced IDL with Mayavi in my thesis. Those images of QCD topological configurations were actually made with Mayavi in my thesis, but they were replacing a similar thing that I had built earlier in IDL. But these products like IDL and MATLAB and Mathematica, they come from companies that employ people doing useful work. And there's an economic model for that. You pay a license, and these people fix bugs, they document things, they do sales, they do tech support. There's a lot of things that work through that model. Open source is not just magical pixie dust that you spray on things and magically that stuff just happens, right? Because somebody does it between midnight and 5 a.m. on Sunday. And so we need to think about this as a risk for science. And I would like to argue that scientific open source is a foundational public good, foundational in the sense that Nadia Eghbal kind of phrased the Roads and Bridges report, which I encourage you to read if you haven't. It's a phenomenal piece of work. She's not focusing on science. She's more focused on like general open source software, Linux, et cetera, kind of general software. But her arguments are equally valid in the context of science, that it is digital infrastructure of the modern era, like roads and bridges, and therefore it needs maintenance and support. It's complicated because these projects cannot be managed in the traditional way where you simply give one PI a bunch of money to build a vertical thing that they put their name on. We live in a world of complex multi-stakeholder relations that require thoughtful management and understanding. Elinor Ostrom was an economist. I think she passed in 2009, I believe, whose work on governing the commons is kind of a key reference to think about this problem, because she did a lot of work on studying fisheries, actually the fisheries in California, and how they established successful models for governing a commons without falling into the tragedy of the commons. And if for any of you who are thinking about these questions, I strongly encourage you to take a look at these at her work and her materials. But there are resources out there. This is taken from the AAAS, the organization that publishes science, the magazine, and they keep track of the federal R&D budget, and its order of magnitude, the total federal R&D budget is on the order of $200 billion a year, if you put everything together, right? $200 billion a year is just in the US alone is real money, right? That's real money. What fraction of science today depends critically on computing? 10%? 30%, 50%? I mean, there's not a whole lot of science being done today where computers don't play a key role. And as we've seen, the scientific and open source R and Julia ecosystems are critical today to the most high-profile projects in the world, right? The LSST telescope, CERN and the Higgs boson, the black hole projects, et cetera. 1% of that budget spent well would make a difference. And so the closing of this presentation is kind of thinking about this, and that we should think strategically about how to do this well and how to get our federal agencies, which actually are interested in funding this. And a lot of people have worked on this, but we need to think how to do the well-spent part. There will be some waste inevitably. I was chatting about this with Eric a couple of days ago, but we have also learned lessons. We've understood what are some features of successful, resilient projects? What are the things that need to be taken care of? Examples like CZI and the Moore and Sloan programs and their approach to funding. We already have some knowledge based on which we can probably build meaningful, impactful programs to get resources. One way that I think about it is that we can fund kind of the backbone of many projects and many communities in ways that then leverage and continue to encourage this broader community that includes industry partners, that can include just the general kind of the long tail of volunteers. I wasn't demeaning kind of open source volunteers in general. I just wanted to flag how there are roles that need to be funded and supported in a more structured way. And I think that would be viable with the kind of resources that are available. And I would argue that are being both inefficiently spent by not contributing in the right places. I think we're losing an opportunity in science, and we're creating risk. That's in some of these projects, they hinge on a handful of people, and those analyses have been done over and over. And so there's also risk to science by not funding and supporting these backbones in a more structured way. A number of organizations are working to complete sort of this picture. We've already mentioned NumFocus, but I really wanted to explicitly thank and congratulate Leah and Andy. They've done over the years a phenomenal job. When we started NumFocus back in 2012, it was an attempt at doing something that would be the right thing, but it took the execution and the dedication and the tenacity of Leah and Andy and others on the team, and Lorena, who was the chair of the board for a number of years, to really get this organization to be one of the key actors in our community. Again, Lorena, on Joe's on education, and Arfan and others on JOS, getting this kind of work to be recognized in the ways that the existing incentives in academia recognize. This has had a huge impact. Interestingly, I saw these tweets go by yesterday from Dan Katz and others who are beginning to see actually the threat coming from the established academic publishers who don't like that the community can create these things, and the Elsevier's of the world are unhappy that our community is capable of doing something cheaper and better than what they do with their models. And they're beginning apparently to actively try to work against it. So we'll see where that goes. The career path for those who want to be in the open research and education world, but not in the traditional tenure track faculty. The European folks in Europe, especially in the UK and the Netherlands, have done a lot of work in that, and it's beginning to pick up. The RSC movement is beginning to pick up in the US. I'm not as deeply connected to that as some of you are, but I hope this is something that will create reasonable, sustainable paths for this kind of work within academia. Mozilla is an organization that has thought a lot about how to lead open organizations. And there's a lot we can learn from them. I know folks in Jupyter, some of the folks in the Jupyter community have taken these workshops on leadership and management and organization building. And I think it's extremely important that we think about that and that we learn from their expertise. I want to flag specifically a new effort that we have from folks connected to, but not only from Jupyter, which is being led now by Chris Holgraf, who many of you know from Jupyter Book. He did his PhD at Berkeley in neuroscience. And Chris actually was one of the folks who took this one of these Mozilla workshops. And we've created an organization called 2I2C, which is a nonprofit that basically tries to take some of the work that we did at Berkeley with this kind of infrastructure for education, work that Jim Colliander was doing in Canada with Jupyter Hubs deployed for research and education across Canada, and some of the work that Ryan Abernathy was doing in Pangeo to scale cloud computing for big data geoscience. Well, all of those things had one problem, which is that we were doing them in academia, but they were there's a lot of DevOps and engineering and actual infrastructure to do. And so we were attempting to create a new organization that can actually offer purely in the science and education space management of infrastructure and R&D partnerships and grants and collaborate on projects, but with a strict mission of sustaining the ecosystem back. So it's being able to actually offer services, because a university is not really in a position to do that well, but where the mission is open science, open education, and fueling everything back into the underlying open source community and ecosystem. And so if you're interested, please connect with us. And finally, I want to flag the work that Ana Rubalcaba and Jason Grout have been doing with the Jupyter community workshops, for which a new call is coming out. And obviously the pandemic has thrown everything to a loop, but please contact us and ping us on the Jupyter discourse, because the Jupyter community workshops are a good opportunity to explore some of these questions. We could imagine a community workshop that is precisely around funding and fundraising and engagement with federal agencies and supporting our community in a more sustainable way. There have been things of that flavor that have been done by others in the past, but there's still opportunity to do quite a bit more. And we have some resources there, and we would invite the community to explore this, because I think we're at a point where we have enough to kind of demonstrate its success, but we also have a critical need, and the resources, I think, are there. The funding agencies are interested. Folks at OSTP and the various large federal agencies that I've had conversations with are actually legitimately interested in thinking about this. And so I think it's a good time to try to perhaps get more resources on the foundational side in ways that can make our communities healthier in the long run. So I will stop there, and I think it gives us a few minutes perhaps for a few questions. But again, thank you all. Thank you for this opportunity. This community is the one that really made it possible for me to come out from an absolutely brutal crisis, as I mentioned at the time. And it was the generosity of folks like the ones that I mentioned, but obviously that was just because I chose to do a thin slice early on in the early years of this for reasons of time, but it really was the generosity of this entire community that has made my career and my life kind of the way it is today possible. And for that, I thank you. And I hope to see you, many of you, in person next year, but it's a pleasure to be here online.
Thank you so much, Fernando. Wonderful talk. I think we do have about 5 minutes or so for a few questions. So if you click over to your Q&A tab in the app, there's some questions there. And Fernando, there are only a couple there, so you could read over those. But as they fill in, I'll moderate those. You can pick one of these, and then I'll move on.
Right now, I see 2 in the Q&A. So Juan Luis Cano is asking about the support for other languages. And it is true that I think the Julia community is rallying around the VS Code plugin, and obviously RStudio is a big player, and that's fine. I mean, I think that excuse me. I think that it's inevitable that there will be exploration and that communities will try to develop tools that are highly optimized for their specific language. I still think it's very valuable to have a baseline of an open architecture that is interoperable. It is possible to use languages in combination. It's also possible within the IPython kernel with Magix to combine multiple languages within one notebook. And I think that has a lot of value in teams that may need a lot of interoperability. But obviously, we're not going to stop. And those communities are also developing interesting and cool things that are different. And they can explore different corners kind of the parameter space in different directions and different approaches that perhaps take better advantage of aspects of their language, or that don't run into specific sort of their alternate engineering decisions compared to the ones we might have made in Jupyter. So I don't see that as a huge problem. It was never our intention to be the sort of one ring to rule them all, the one environment to rule them all, but rather to offer a vision of an open, interoperable architecture that could support an ecosystem. And I think as long as that remains true and we provide benefit to many communities, also to the smaller languages. Julia and R are big communities now, and they have a lot of sort of firepower, but it's possible to write a kernel for a smaller language and offer it to the world. Actually, IDL, a few years ago, I went looking, and it turns out that if you look around for how to run a notebook for IDL, they explicitly say, you get your IDL license, you install Jupyter, and then you put the IDL kernel file over here, and you're done. So ironically, 15 years later, IDL is using Jupyter to give their users a notebook environment, and I think that's a valid use case. So I hope that answers the question. The next one, could you please talk about how you started integrating your physics work with programming? Was it typical at the time? Well, I don't know if it was typical, but I was doing very early on. I was doing computational physics in Colombia in Maple, actually, with Maple notebooks before even Mathematica, and in that process, I was already using computational systems like Maple that are symbolic to develop numerical code automatically exported to C and C++, it was C++ at the time, that would then be compiled into an executable for, in my case, the three-body problem. The electrostatic three-body problem is what I was working on in my undergraduate thesis. And so I was already kind of woven into this notion of using computational tools from the theory of the physics and the equations and the symbolic formulation to generating code to running simulations back in the 90s in undergrad. And so it did come quite naturally. And I also had to teach with those tools, and it was miserable because teaching without actually licenses for all the students to these tools was a horribly painful experience back in the day. And so a lot of that was actually the motivation for me to then go ahead and start trying to build open tools that I could use to share with others, that I could deploy to as many students as I wanted, and that would allow us to focus on the science rather than on the complications of pointers and C and whatnot, which was what happened. So it came naturally to me because my mentors in Colombia, that's what they taught me kind of in the 90s and as an undergrad. And it did put me kind of on the path thinking about tools in this way. But I don't know how typical it was at the time to be combining these tools in that way.
Thanks so much for those answers, Fernando, and thanks for the great talk. At this point, I think that about wraps up the time we have, and it's time to head off to the individual sessions. So thanks again, Fernando, and enjoy the rest of the day, folks.
Wonderful. Thank you, Eric. Thanks to the SciPy organizing team. I know it's a lot of work having put conferences together, especially in these conditions. So thank you all, and to this community for the amazing work that you all do, that inspires us, and that hopefully we'll continue doing for a long time to come. Take care.
Great. Goodbye.